We're doing the radix sort, and to do this we need to come up with an unsorted array of numbers. It's an integer array that we're going to be using, so our output will look something like this up here. We first need to sort in ascending, which is what the first output is. We sort it in ascending, and then we need to sort in descending, and that's after we reset the array to its original order and then sort it again. So this will be our output, the future output, and that's only after we code it. So those are those instructions. We also have this Google Docs that provide more instructions, and the link for this will be in the description below the like button. Just a quick overview, this is what it will look like. So knowing this, we need 4 classes right here. We need a driver class, which I have as main. We can refactor this by making it a driver. So we'll go rename, and I'll just call it driver, and then we'll update all references and click finish. And so now it's a driver class. Then we need no, queue, and radix classes. So we're going to do this all in one Java file. We are going to have public, we're going to have node, and then we are going to come below that. We are going to have, or I'm sorry, that shouldn't be public node, that should be class node. We're then going to have a class queue, and then lastly we are going to have our class, and then it's going to be radix for our radix sort. So those are our 3 classes. Now we have more instructions here. This is pretty important. We're going to be using static methods inside of our radix class, so we don't have to make an instance of our object. Of our class. We don't need to make an instance of our class. We're just going to make everything inside of it static. And then there are some general rules that we need to follow, and so on and so forth. So now we are going to look at the actual code for this. We're going to start off with our main method. There's a few things that we need to do inside of here. First thing that we're going to do is make our array, and we're going to be hard coding our array. This means that we're not taking any user input or anything, so we're just going to have int arr for array, and then we're going to set this equal to, we're going to have these braces, and then inside of here we're going to have random numbers that we're going to use. These can be any kinds of numbers, so just have a good bunch so that we can compare them, and you can write them in like this. So this is our array of numbers that we're going to use, and now we can copy into our array. So inside of our radix class, we are going to need to have a copy method. And the reason why we need a copy method is because per the instructions, we need to reset our array after we write it in ascending order. So to copy this, we will write out copying array, and then we will make our copy. So we will do int, and we will just call this arr copy, and then we will set this equal to a radix dot copy. And then inside of here we want to pass in our arr and also our arr dot length. And so this will give us the entire array and the length. So we can highlight over this and we can create the method inside of here. It's public static int copy, and then we pass an int arr. This is a array and we're returning an array. Then we have an int length inside of here. So in here we're going to rewrite this, and then we can code this. So for the copy, all we're doing is we're rewriting our array. We're going to make a new array that we're going to return. We'll just call it temp. We'll do int, we'll have the array symbol, call it temp. We're setting it equal to new int, and then inside of here we are going to have our array size. And that's because we want this array to be the same value as the array we're passing in. So we're going to have length inside of here, and we're going to come outside of here. Then we're just going to be in a for loop, and then inside of our for loop we'll just do int a is equal to 0, and we're going to run a as long as it is less than length. And then we're just going to do a plus plus, and then outside of here we will be inside of our for loop, and we'll just do int, and then, or I'm sorry, not int, because we don't want to make a new array. We'll do temp, and then inside of here we'll do a, and then we're going to set this equal to our arr a. So this will basically copy whatever is in our array at this position to whatever is in, or whatever we need it to be for our temp. And then once we're done with all of this, we're going to break out our for loop, and then we're just going to return temp. And so now our ARR copy inside of the main method will have the temp inside of it. So that's for copying the array. The next thing that we need to set up is when we get the max number for our indexes. So we're going to use a method, and we're going to call this. So we're going to write getting the max number of indexes. And the theory for Radix Sort is linked below the like button in the playlist, chapter 4. You can do a Control F and just look for Radix. And that's like how we would go about thinking about it. So getting the max number of indexes in here, what we're going to do is we're going to do int, and we're going to call it max base. And then we'll make a new method inside of our Radix class, and we will do radix.get max length. And then inside of here, we're going to pass in our ARR and also our ARR.length again. So we can hover over get max length. We can click create new method, and this will create a new method for us. And so this is our new get max length. So inside of our get max length, what we're going to write is code to get the actual base, the digits in our base. And since we're dealing with the base, instead of length, we will call this base. So get max base. We're really getting the max base length. So inside of here, we're just going to set int max equal to the first array value. That way we're just initializing it, and we're not wasting any space. And then after we do this, we are going to find the max value in the array. So inside of here, we will have a for loop. That way we can run through every single value in our array. We're going to do int a is equal to 1. And the reason why we're doing a is equal to 1 is because we've already looked at the first value right here. We're going to run this as long as a is less than length, and then we're going to do a++. And then outside of here, we are just going to compare. So we're going to do if our max value is less than the array index method, or the array index element that we are currently looking at, we are going to set max equal to that array index element. And that's what that's going to look like. Once we've done with this, we can come down here, and now max stores the longest integer inside of max that was in our array. And so what we can do is we need to now get the base of it. So getting the base, we are going to initially set int max base equal to 1. And we're going to assume that we have at least something inside of here. And so if we have 5, right, then the max base is 1. If 5 was the biggest number, if anything from 0 to 9 was the biggest number, the max base will be 1. So inside of here, after that, we're going to write getting the largest base. And this is what this for loop is for. So we're going to do for, we're going to do int I is equal to max. And we are going to kind of deteriorate this value until we get to the very end of it. So we're going to run this as long as I is greater than 1. So we have I is greater than 1, and I is some arbitrary value. I usually do like a, so we can change this to a if we wanted to. So this is any value. Int a is equal to max, and so max is the max value here. And then we're running this as long as our basically max value is greater than 1, and we're doing the a is equal to max because we don't really want to touch the max itself. And then after we do this, we are just going to do a divided by 10. In this way, we can look at each base value. So if we had something like 1, 2, 3, comma 4, 5, 6, the first 10, we'd be looking at this 6, and then we'd be looking at 5, 6, 4, 5, 6, 3, 4, 5, 6, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So now we can go inside of our for, and this should be a divided by equals. And so the divided by equals means we're basically saying a is equal to a divided by 10. And then inside of our for loop, we are going to set our max base equal to the max base times 10. And then outside of our for loop, below it, we are going to set our max base equal to the max base, and then we're going to divide it by 10. That way we can, like I said, deteriorate through it over time and look at all of the different values, because 1, 2, 3, 4, 5, 6, we want to see the base of this. So we would look at this, and then, well, we would take this out, and this, and so on and so forth, until we get the largest base value. And if we have this 1, 2, 3, 4, 5, 6, we would see that our longest is 6. We have 6 digits in here. And then after we're done with all this, we're outside of this for loop. We're going to come underneath this max base right here, and then we're going to return the max base. We'll write more about that up here, so we'll do just a comment like this, then we'll move this over here. And so in here, we are getting the max base, which is the number of digits for our largest integer. Our parameter is the array that holds our values, and then the length that we're passing in is the length of the array, and then what we're returning is the number of digits for the largest integer. And so those are our Java doc written out. We can do the same for our copy method as well. And so we have the setup for our initial code done. We have the driver class written out, we have our copy, and our get max base. From here, afterwards, we are just going to finish setting up the node class. We are going to set up the queue class as well. It's important to note that this is all leading up to sorting the array in ascending order, and then resetting the array, and then also sorting the array in descending order. We can actually reset the array right now. After we do the array in ascending order, we're just going to set ARR equal to ARR copy. And so that will reset our array. Now we're going to deal with the ascending and descending. In dealing with these, we are going to have to build our node class. And the node class is really a helper for the queue class, because what we're doing with the queue is we are making kind of buckets, and that's explained more in the actual Radix kind of thought process. But queues are used to make buckets for storing values in and then sorting them. And then nodes are used to make the queues. So next we're going to be working on nodes.